Welcome to this week's edition of Frivolous Gravitas, where we will be getting into something a little more topical than usual. We will be talking about the virus, specifically the current coronavirus, which has now become famous due to its, imposition on all of our lives all over the world. So for this, we've brought in our resident scientist slash pharmacist slash person who knows more about this stuff than we do, Megan.
Hello.
Yeah, there she is. So we don't know if this is gonna be covering anything that other channels have covered, or stuff that bigger, more authoritative sources. But this will be a discussion on essentially the basics of what the coronavirus is, what's been done, and our look at the way it's been presented to us, the way we've been dealing with it, as well as our scientific and data literacy with regard to this as well. So I think one of the things that we could start with is start with the most basic aspect of it, and we'll move up the complication ladder. And so I think I'll turn it quickly or directly over to Megan, and I'll just ask the question: what is a virus?
Okay, so we can start the most basic form there. So my professors have gotten in fights over whether viruses are alive or not, so I'm not going to go there right now.
Yeah, that's a whole other thing.
Yeah, I had a student threaten me once too. So anyway, the
scientists.
You get really passionate about things that are important to us. So,
okay.
But you've got your cells, and I talked a little bit about this in the other podcast I did with you guys. But viruses are like they have a particle, and they've just got DNA or RNA, just nucleic acid inside, and it's just instructions to make proteins, and then proteins to make it, and that's it. They can't replicate without hijacking another cell. They're just instructions in a box, basically.
So that's why don't we call it a parasite? What's the difference between that and a parasite?
Some people do call viruses parasites, but it because like parasites sometimes can. You know what? That's actually a good question. But a parasite is something that can't live without something else, and like viruses are also kind of like that. But parasites like have
life.
They have yeah, they'll be like bacteria, so they'll have like process, like they can make their own proteins out of their DNA, whereas a virus can't make protein. It needs to hijack our systems in order to make proteins.
Aren't they on a a lot smaller?
They are much smaller than like
anything else.
Yes, like if you're looking on a microscope and you're looking at like a human cell, like human cells also vary quite a bit depending on what type of cells, but like your typical white blood cell, you'll see a bacteria. It'll be like really tiny on your microscope field, and then you go zoom in on that bacteria, and then you probably you can't see viruses on light field microscopy, but like you'll go down another like couple orders of magnitude in order to see viruses. They're very, very tiny. And so that's our start. Yeah.
Now I kind of asking leading questions here. Is there only one type of virus? Because like we talk about
there's so much. There is so much more diversity within viruses, because there's so many more ways that they can exist. Like you can have a virus that doesn't have DNA; it's just RNA, such as coronavirus. There, I said it. And so there's so much more diversity. Actually, the way that we've sorted them and grouped them. I took a virology class 5 years ago, and what I learned about how some of the things are sorted has changed. So they're doing a lot of like changing the phylogeny as we discover more and more viruses and do more and more sequencing and stuff. So interesting,
categorization, but in order of
yeah,
life.
You're trying to find out like what came from where. So like these two viruses are similar, so at some point they have a common ancestor, but where was it? And like that puzzle. Lots of work being done there. Pretty cool stuff, but I won't get into that because it's very, very, very technical. But I'll talk about coronaviruses a little bit. So they are enveloped positive sense RNA. So I'll explain what that means. So enveloped just means that they have a lipid membrane. So they've got their RNA inside, and then they've got a protein capsid. It's like in the shape of a D20. And then there's that's it. Then there's a lipid membrane around the outside of it. And it steals the lipid membrane from the animal cell that it's infecting.
Lipids for the layman? Fats? Like a fat particle,
it's a
molecule?
But like specifically your lipid membrane is like, there's a head that really likes water and then a tail that hates water. You know, when you mix oil and water together, they don't mix. So like the inside of the tail is like the oil, and then the outside of it likes water. So then when you put those together, you get like two sides that like water, and then it likes lipid in the middle.
Oh,
so then it automatically
and hydrophobic, right?
Yeah, exactly.
So that acts as like
that's your phospholipid is what that's called. But you get a phospholipid bilayer, so that's why you get like a lipid in the middle. It's a very good way to like separate two things, but things can still pass through it. So
and that's another way that like cells can store charge and move around.
Yes.
Enzymes and nutrients sometimes only get
you can create a charge through there and that's actually how your cells generate energy, is by creating like a pH barrier, so it's more acidic on one side than the other, and then you have
mitochondria do that too, right?
Yep, that's exactly what I'm talking about. Your electron transport chain. It's the same thing. It's hard to explain without pictures, to be honest. But so they has the lipids on the outside. So the lipids, allowing it does help. It's where the spike protein, or sorry, let me try again. But the lipid membrane, it makes it actually less stable. So coronaviruses, like, it can't quite live as long on surfaces and things than other ones, because the lipid will break down quicker than the proteins will. So that's why the enveloped is important. Enveloped is also important because they're easier to destroy with like alcohols, hand sanitizers and stuff. So that's why hand sanitizers are more effective for enveloped viruses than for non-enveloped viruses.
Like
so
that's viruses.
Is that related to the UV exposure too? Like ultraviolet breaking them down?
Ultraviolet usually affects the DNA directly. So I think UV is effective for both.
So it would leave the virus membrane intact, but it would destroy the RNA inside the virus?
Probably. I think it would just destroy everything, to be honest. Like, yeah.
So,
and of course, I can't think of a single naked virus right now. Like, there's hundreds.
HIV is one of them?
No, I can't remember. Just wait 1 sec. There's so many of them, and it's just they're all gone out of my head. And then it just gives me groups. Anyway.
Well, while you're looking for that, I stumbled across something neat while preparing for this episode. Apparently, there's a theory out there that the way that cells develop nuclei to store RNA or DNA, I mean, was originally from like a bacterial cell or a plant cell or something that had absorbed a virus, and the virus maintained its membrane.
Yeah.
Or it was inside a bacteria, and the cell absorbed the virus, or the bacteria with the virus in it. So there's some evolutionary component.
Definitely some because mitochondria are bacteria essentially.
Well,
bacteria that we've essentially domesticated into our cells, for lack of a better term, and they can't live on their own anymore. Well, the thing is that they still have their own DNA set, and they're like DNA is like relatively similar to another specific class of bacteria that still can live on their own. That I don't remember what they're called at the moment.
Yeah, I think a common misconception is that viruses are just all bad and we should wipe out all viruses. But a lot of people don't really pay attention to the fact that viruses are part of how we evolve and exchange DNA too. Yeah,
I knew it was something obvious. Okay, the naked virus that I was thinking of was polio. So polio is harder virus to destroy. Also, rhinovirus, which is the most common cause of the common cold. So just to step aside on the common cold for a second, it's actually caused by several different types of virus, like hundreds, thousands of different types of viruses can cause the common cold, including types of coronavirus can cause it as well. So there are people, I worked at a hospital over the summer where we did have a case of someone that had coronavirus, but it was just like one of the ones that give you a cold. So they were in the hospital for something else. But yeah, so there is like other types. while we're on the subject of other types of coronavirus, I also will bring up SARS Part 1, which it's a very similar virus to the one that's around right now. But it's didn't quite get the same spread as SARS-2. There's a few key differences, but
why didn't it spread as much?
Well, one thing, awareness, but two, it just doesn't spread. It's just not as effective at spreading. It just wasn't as good at it. And there was like some pretty hardcore control measures, and it was found quite early. Like by the time most of the world realized that this was going to be a problem, like there was entire cities in China where everyone had it, right? So, and like SARS was not a huge amount of cases. It was in the hundreds of cases, I think, I want to say.
Yeah.
I was still not paying attention to the world when that came out, though. And then there's also Middle Eastern respiratory syndrome as well, or MERS, and that one still pops up in a lot of Middle Eastern countries. It's floating around there, and it's been around there for many, many years. So that one does come up still occasionally. It's just, again, it doesn't spread as easily, so people still get it, but it just doesn't have that ability to spread quickly. So I'll talk a little bit about so we know the virus is a ball and it's got RNA in it. And I did mention the term positive sense RNA earlier, and I did say I would define it, so I will. So it's single-stranded RNA, so there's just one strand. And what positive sense means is that it can be immediately turned into a protein, translated into a protein. So you have your little code, and it's the proper code to just immediately turn that into a protein. Negative sense RNA needs to go through it needs to be turned, it's like the opposite of your code. So you need to turn it into the proper code. So it needs to be processed first, but positive sense RNA, it just goes immediately to be translated. And then once it gets into the cell, your cells, then your cells will start making proteins right away. And then those proteins will process the other proteins essentially, and then make the viral particles out of that. So it's hijacking your system. And then when your system's busy doing this, then it can't do any of its other functions. So it will die either because it just can't do its other functions, or because your cell notices that something's wrong, and it essentially flags your immune system to be like, hey, I'm broken. And then your immune system will get rid of it, for lack of a better term. And
on that note, do you mind if I just interject quickly?
Go for it.
What makes that different from another virus that like permanently, like, you know, there's long-term effects to a lot of these COVID cases they're realizing now. So is there like some kind of simple not correlation, but is there a simple reason why some viruses just come and go and get flushed out of your system, and others like HPV and herpes and stuff that stick with you for a lifetime?
It's not simple, no. Like herpes are smart. They hide out in your nerve cells, and your nerve cells don't divide, and your immune system doesn't like get inside them, like you can't see inside them, right? So they're smart viruses, and herpes will again start replicating when you're in a period of stress or your immune system's not working well. So like big easiest example is like chickenpox, shingles. So you get chickenpox when you're a kid. And then when you're older and your immune system's not as good, maybe you're stressed about work or whatever, then it can come back as shingles.
It seems like it's like a evolutionary thing, because you get it's because if it's the purpose of a virus is to find matter that it can use to create more viruses, and so the ones that are going to succeed and last the longest are going to be the ones that can find a niche where they can do that most effectively.
Well, and one of the interesting things too is, we personify viruses to be like, but
well, like, you said
they're looking for strategies. Like by smart, I mean that they like all they do is exist more. That's all. Like that's the only thing. They're not thinking, they're not alive. They just exist more. And things that are successful at existing more because they like found a cool mechanism, we'll call it smart, because we're biologists and we personify the heck out of our viruses and bacteria and stuff because it's cool and it's easier for us to understand. But really everything's kind of just happening, and things that are good at happen lots.
So you can kind of liken it to a sedimentary rock. So over time, if conditions are favorable, sediment will become sedimentary rock just out of like compression and time. But if the situation's not favorable, you don't get more rock or anything like that. You just get less rock, but it's not that the rock is reproducing, it's just the conditions. Sorry about the phone there.
Yeah, no problem.
You're just popular.
I know. He's got so many friends. No one calls me like that. Anyway, it's just like evolution stuff. Like if you're good at it and you're able to make more of yourself, then you do.
Yeah, I feel like we could dive into existentialism and spend 6 hours talking about like maybe we're just viruses, but let's not do that and go back to the relation of viruses to people.
Okay. Yeah. So COVID will usually infect you. So we'll start with how it gets in. So usually people are infected most often by breathing it in from something. So usually somebody stop breathing.
Stop breathing.
And so what usually happens is somebody who is carrying the virus will cough or sneeze or talk moistly. And yeah, we're Canadians. So this will spread respiratory secretions that somebody else will breathe in. And then that's the most common way of transmission. You can also get transmission through, like, the word is fomites, but that just means things. So like doorknobs, elevator buttons, desks, chairs, whatever. So like you touch a desk that someone with COVID was sitting on and coughed on, and then you like touch your face. Your eyes are a good way for virus to get in, or your mouth, or you scratch your nose or whatever. So, but most obvious is the respiratory secretions. There has also been so we'll talk about this now because I knew this was going to come up, but there has been some evidence of airborne, but it's not the primary mode of transmission. So it could happen, but it doesn't happen very often. And like in hospitals, when nurses just take respiratory precautions, that seems to work fine, well enough. So that's the thing with that. So there was a thing where we were like, it's airborne, like everyone panicked, because when things become airborne, they're a lot harder. And I guess I'll explain a little bit why. So respiratory secretions have much bigger particle sizes. So we talked about how small viruses are, but viruses aren't hanging around when you cough. Like the ones that are like the ones that are going to infect other people are ones that are in big droplets of like spit and mucus and water. Like those are the ones that are going to infect you and that you'll breathe in. So you have like a specific size that will get into your lungs well, and those are the ones that have the most virus, and those are the ones that'll make you sick.
Well, still a tiny, like relative to what we're used to, it's still a tiny drop, and within that tiny drop, it's an equally minuscule virus.
Yeah, we're
it's big compared to
we're in the dimension of micrometers here, like a few micrometers. If you use an inhaler, you're looking at like 5 to 10 micrometers of the particles that you want when you're using an inhaler to like get inhaled stuff to your lungs.
Right. So is that the size of the water particle that the virus would be?
You know what? I would have to look it up, but it's going to be somewhere in that vague range.
Okay. I think the water particles are bigger because they have to be dense enough to carry the virus when it attaches to it without.
Yeah, and like each particle isn't just going to have one virus. It's going to have like hundreds, thousands of viruses in it. And then you would have to get several of them. So another thing with viruses is that different viruses, you need different amounts. So like to get sick with salmonella, you need to take in like millions of salmonella particles. But then there's other viruses that you can get 6 of them and get really sick from it. So coronavirus, you still need like a decent amount to get sick from it. Maybe not millions, but if you get 6 coronaviruses on you, your body will probably fight that off unless you're like very, very immunocompromised or very, very unlucky.
So like, obviously air density plays a big part in that, because if you have more moisture in the air, then it's carrying more water particles and stuff. But on the same token, if you've got cold, denser air, it's going to condense into vapor a lot easier, right?
Well, the thing is,
any difference
if someone coughs at you and they're 4 meters away, then it might make a difference. But if you and I are standing half a meter apart and not wearing masks and talking at each other, the air conditions aren't going to make a difference unless there's like a wind blowing like 80 kilometers an hour, like crosswind, that might help prevent. But like just at this scale, even if it's like if we're in a desert and then we go to, the Arctic or whatever, like it's still, if you're close to each other and talking at each other, then you're still going to be getting it
So the social distancing guidelines and like meeting people outside, that's been pretty consistent right from the start of the outbreak. So that's still accurate in your view?
Yeah. Yeah, it is. And it's like that like every little piece, like masks and social distancing together seem to be like enough to prevent most of it. If we all wore like bodysuits and goggles, then that would also like decrease the chance of spread more. No, but it
They'd
would
just be
decrease the
wearing their
chance.
bodysuits around their waist, just like they wear their masks around their neck.
It's just horrible. Oh, that was a terrible image in my mind. Why'd you do that? No, the point is that there's diminishing returns, right? So, and there's only so much that people will like. Some people will follow everything that comes out to a T, but you need to like have a solution that's actually feasible. And that mask and social distancing are feasible. We've seen it. Some people don't like it, but just because you don't like it doesn't mean that you can't do it.
Now that's with COVID that we've seen that.
Yeah.
But if we have a different virus, we'd have to take different measures.
Yeah, it would depend on how that virus is spread.
For an airborne is always going to be.
Yeah. Well, that's the thing. If it's like something like Ebola doesn't spread through respiratory airborne stuff. It's mostly like contact body fluids sort of stuff.
Which is why it was easy to set up quarantines.
It wasn't quite as difficult. Easy. Still hard, and it still can be quite infective, and it's a very horrifying disease. It like liquefies all your organs. Super messed up.
Tragic.
It was, yeah, and it's not pleasant at all, and not having proper facilities to deal with it was also a big issue with that. I do know a couple people that were actually with CSF during the Ebola outbreaks, and they were like helping out a lot. And yeah, they didn't talk about it much. So
did they get the recent Ebola outbreak under control, or is that still going on?
You know what? I don't know.
They had a recent one just within the last 4 weeks or so, I guess.
Yeah, I haven't.
Beginning of April right now for anybody watching this after the fact. But
where was this? I haven't.
In Africa.
Oh.
It's a big continent, but I can't tell you which country exactly.
Things definitely get pushed aside because of COVID. Like, have you read an article about the flu this year yet?
I read about
seen
how
anything
few
about
flus
it?
there are.
Yeah, like that's pretty much it.
But because of the social distancing and masks, there's been less.
Yeah, there's been like even like less sickness in like babies and kids. So,
which is ironic, but
really
it's nice. It's working.
Yeah, well, like like hospitals have talked about there's just less infectious disease. There's still like community acquired pneumonia, but that's mostly just because sometimes you get pneumonia not because you get exposed to something, but because you just aren't strong enough to fight off the thing that you're always fighting off anyway.
Well, sometimes it's just from like if you're bedridden, you can get pneumonia and fluid in your lungs just from laying down too long.
Well, if you're not swallowing, if you're not able to swallow properly, and then you can get really bad pneumonias from that. Then take lots of antibiotics, which I could talk about a lot, but we'll try to stay on target here.
Yeah, I think antibiotics would be an entirely different.
That would be its own episode.
Yeah, although that would be a really interesting episode.
Though
to talk about.
I will say that like with coronavirus, you can have problems with like intubation and aspiration pneumonia. But anyway, we will continue with
before you keep going. Actually, a lot of people, including some med students that I know, are not aware that we've discovered a long time ago there are things that you can do to treat COVID in hospital that we didn't know from the start. Like originally they were just doing the intubation on ventilators and stuff as just a matter of protocol, but they discovered that by proning, by changing the body position of the patient onto their chest, that alone is enough to keep them off the ventilators in a lot of cases. And things like that kind of go under the radar on the news. You don't really hear about how we've actually learned to treat it better.
Yeah, I have heard about that from nursing, actually. Some sort of nurse that I heard about that from, that like you can just change positions, and like sometimes arts get lost, and sometimes medicine tends to get a little bit too focused on drugs that make money.
I think the lay people also, like people like me, are who don't know and aren't aware of what's going on in a hospital. If you're not paying attention, you'll be seeing, if you're watching like CNN or Fox or whatever, you're going to be seeing what the news thinks you want to see. And that's going to be fear and disaster and this and that, because, look at all these new procedures that we've done to, help with the thing. And like, here's what we're doing. Here's a bunch of hope. And hope doesn't sell newspapers. Fear does. Well, at least that's what they think. So we're getting a constant stream of like fear, fear, fear. And we just don't hear any of this because we are innovating, as you guys both have just like given us 2 examples of that. And we're not hearing about any of these innovations unless it's related to the vaccine, which...
And people love talking about vaccines because vaccines are controversial.
Yes.
At least now they are. They weren't for many years, but they're more controversial now. And it's this rollout thing because everyone's supposed to get one. And how do we get it to most important people first? Who defines who's the most important people? And why am I vaccinated? And other people that probably need it more than I do, not.
And some people, they gotta like rule out lost causes too. So some of the times it's like hip replacements for seniors. They'll say after a certain age, you're not important enough to somebody else who maybe needs it less. And
there's also another big point there is that some people just will, like, if the chance that someone's gonna die during surgery is like over 50%, then no surgeon's gonna do a surgery unless they're going to die from whatever they need to do surgery on, right?
Yeah, so it's
at some point risk benefit is not going towards do it.
So it's not malice or like ill intent or people being greedy, but there are legitimate ethical concerns to how you pick and choose people, because people are going to disagree. Fundamentally, they will disagree on how it's done.
Yeah. And like, I think like, at least where I am, that's like mostly age. But then if you have certain chronic conditions, you can get there. And actually, this is a good lead into risk factors. So I'd like to talk about risk factors and what we have found by looking. So I'll start by talking about, I just pulled up a study that was on CDC about like 2,500 people in the States. This was last year in like February, March. Where 2/3 of people were over 45 that got COVID. 80% of the deaths were in people over 65, right? So mostly affecting older adults. And the people that are aged like 18 to 34 accounted for only 5% of the adults that were hospitalized, and they had only a mortality rate of only 2.7%. And those that did die were more likely to have morbid obesity, high blood pressure, and to be male. So it's like age is a factor, and it's probably one of the bigger factors, but the other factors that are also associated with age, so you can't really pull it apart, but you've got cardiovascular disease. So cardiovascular disease is a big term. Can mean high blood pressure, can mean high cholesterol, could mean you've had heart trouble in the past, you had a heart attack maybe, or you've had to get stents because you have angina, or you have heart failure, what's whatever.
A stent?
It's a surgery that you get. Basically, you get a blood vessel in your heart that's like mostly blocked, but it's like a stable block, like it's a stable wall, but there still can't get very much blood going through. So then if you do exercise, then your heart can't quite get enough blood, and then you get angina, which feels like a heart attack. You get the crushing chest pains and all that horrible stuff.
You slide the stent into the blood vessel and basically hold it open.
Essentially you just have to, they used to be the old one, they have metal ones and like more fancy new ones that like elute drugs so you don't get clots forming on the stent itself. And then, so they have those, and then it basically just holds it open, and it's kind of like a cure, but it's not, because you still have all the risk factors, so it can happen again.
Well, it keeps you alive longer, which is...
It does. But like it's a cure for the angina, essentially, but it could come back because you're still living in the same body. And the things that caused it to develop are still there, right? So anyway, cardiovascular disease, that big umbrella of anything that's affecting your heart and your blood vessels. Diabetes is another big one. So type 1 and 2. Diabetes, chronic lung disease, which means asthma, COPD, generally people with worse control. So COPD, in case you don't know, is chronic obstructive pulmonary disease, like 95% or something, like just crazy. Most of them are caused by smoking. Some people smoke 3 packs a day for their entire life and never develop COPD. Some people smoke a half a pack a day for 15 years, quit, and then develop it when they're 65. So it's kind of depends, but it's smoking is a factor in almost all of them. There's a couple genetic diseases, but I won't get into that.
But that's it's important to point out all this stuff, mostly because that test you're referring to happening in the States, over 2,500 people. The States is like uncharacteristically obese, diabetic, heart disease, and middle-aged.
The issue with the States too is there's a lot of people that don't have good health care, so they only get treatment for their diabetes and blood pressure and stuff when it's really, really, really bad.
So much of these like external factors, they should just be like, fringe variables or whatever. But in the States, any study you do is dramatically disproportionate to the rest of the world just based on its demographic alone, because they sort of hit every one of those check boxes.
I will say that Canada's not terribly different in terms of demographics and like disease, but like sometimes
the US is always in a lot of studies. It's always because of their population and the type of society they have, and just their weird circumstances make them in almost every study the exception that proves the rule.
I will say that the numbers I read out earlier were pretty similar to what they were seeing in China as well, in the Wuhan region, with like mostly older adults being affected.
But no one got coronavirus in the Wuhan region.
Oh, sorry, only like 500 people in China have gotten coronavirus. I'm sorry.
Yeah. The data from China are a little bit suspect.
I'll just say, like, I did read, where did I put it? That there's been 125 million confirmed cases in the world. It's actually closer to 130 now. I checked yesterday and it was over 130 million. But like, and it makes it like, I will say that not every country has the same level of reporting and is doing the same amount of testing, right? So if you're not looking for it and you don't have the infrastructure to look for it, then you won't find it. So it looks like there's less. So it says 130 million confirmed cases, but there's probably more than double that. Like way, way more people have gotten this virus. It's just they didn't get tested. They didn't have I remember at the beginning of the States, you had to pay to get a test. So like...
And the president of the United States at the time was discouraging tests from being done because it looked bad.
That was not...
shouldn't even be part of the discussion. And it actually turned into ruling and governing the approach to the rollout of the vaccines.
And there was all those problems with bad vaccine tests as well. And like you get a vaccine.
There was some like point of care, like fast tests. Some of the fast tests were like not super accurate, but like the thing is, I will say, like, as someone going to school for healthcare, we do spend like quite a bit of time talking about like sensitivity and specificity and false positive and false negatives, and like you get, like, for instance, there's a strep test that you can get in a lot of places, where you can walk into a pharmacy and pay like a few bucks and get a test to see if your kid has strep throat, and they're not like totally super duper accurate. So if they're a negative, then you send the kid for more labs if it looks like they might have it. Like they will miss some things. So but you're supposed to understand that before you issue tests. But if the tests don't have good tests on them, then you don't have good data to rely, and then you're not sure how reliable your test is. So and everyone was trying to get everything out so quickly, and there was so much demand for it that things were not being done probably as like... Here, I'll give you an example. If I was to make a new vaccine right now for like, I don't know, some disease that we already have, if I wanted to make a new vaccine today and I started doing research right now, it'd still take me 10 years to get it to market, at least.
Why is that? Like,
why
don't we go through the workflow there?
So like for vaccine studies, so the thing with like the coronavirus ones is they took a lot of stuff from like viruses for MERS and SARS-1 and other like mRNA vaccines have been looked at in cancer research as well. So like a lot of the pre-research was like kind of mostly done already, but like the pre-research is you're studying like the antigen. So what are you going to attack, and the agent itself. So the coronavirus, and you're looking at like epidemiological factors. So like the beginning parts is all like, you need to know what you're doing, essentially. And then you'll have preclinical studies. Those are in animals generally. They might be in test tubes, but you're looking for like how much of immune response does it give people. You're injecting rats and seeing how that works, and then measuring titers of antibodies. I should probably explain what that means.
Please.
All right, we're going to back up to immunology. So your immune system has two parts: your innate immune system, your adaptive immune system. So your innate immune system includes things like skin and mucus and like
Nose hairs.
cells that you have that just kind of divide up things that look bad. So, and that's not very specific.
Passive and active, because like
I'll get there.
Yeah. Okay.
Yeah. So innate is it's non-specific, so it's something that kind of might look bad, but it's not. It doesn't recognize specific sequences. So then you have your adaptive immune system, and that involves your T and B cells, which I'm sure most people have heard of. And that one like can specifically attack things that aren't you. So you go through a system when your T and B cells are being developed and existing, where they learn what cells are you, and then the ones that would attack that just don't exist anymore. So then you just have a bunch of B and T cells that recognize anything that isn't your cells, in theory.
Cells.
So when you get something new that's not part of you into your body, then these B and T cells will see that through different mechanisms, which are complex that I won't get into, but they see that there's something different, and then they go, hey, wait, that's not me. And then they work in, so the B cells, what they do is they make antibodies. So antibodies are little proteins. They're all like very similar at the bottom, but then they've got a little sequence on the top. Like they look like little Ys, but there's like little parts on like the end of the Ys that like where there's two of them, and they recognize very specific protein sequences, protein and like sugar sequences. So you'll have one that's like against the coronavirus spike protein, which is what I have from getting the vaccine. So then if I do actually run into the coronavirus, then I have these antibodies floating around everywhere in my blood, and they'll see that, and then they'll attach to it right away. And they're like, yeah, this is bad, clear this, get rid of it. So once they attach to it, then your body sees that there's an antibody attached to something and just gets rid of it, clears it. So that's, your T cells do the same thing, but through a different, more complicated mechanism. But like the antibodies are what's more important for vaccines. So when you get a vaccine, which vaccine? Let's do chickenpox vaccine, because we talked about chickenpox already. So you have a baby and you give them the chickenpox vaccine, which they give at the same time as they give MMR now. And so then what that does is then your baby's immune system sees a little bit of virus or a little particle, and it goes, wait, that's not me. So it builds up these antibodies. Once it sees it, then it knows that that's something that's a possible threat. So it builds up antibodies, makes a bunch of them. And then if they ever run into chickenpox virus in the wild, they'll see it and be like, yeah, I know that's a bad guy, and I know I need to get rid of that one. So it'll specifically attack it very strongly. Yes, Jordan.
I've got a few questions. So yes. In my mind, you got all these little cells going around with different detectors on the end of their little nodes. And now, is there an upper limit as to how many of these how many variations of things we can detect? Because I'm thinking of like, you have a book, and then every time you see a certain word in that book, you add it to the index, but eventually the index is going to become longer than the book.
So that kind of makes sense. But the thing is that you already have the index. Okay, but the index doesn't start making stuff more until it sees it once. Because if it did, it'd be a huge waste of energy, because there's like millions of cells that are waiting for the thing that they will recognize to exist. So
which is
when
why
you
we don't
first
have
time
inherent immunity, because that would just take up too much.
Yeah, and it's so, and this might help, but the first time you run into something, it takes a while, like at least a couple days for your antibody response, because it'll recognize it. And then it'll be like, oh, wait, this is a threat. Like this thing is an actual threat. So it'll make it, and it'll take a few days to clear it. But then the next time you run into it, you're primed, you're ready for it. So you can you know that, but like the point is that the index is already written.
Okay.
So it's more like bookmarking a pre-existing index rather than establishing a new set of indices, right?
Yeah, because
like they're there already.
These immune cells going around searching, and there's no room for the blood or anything else to go to.
Yeah, well, the immune cells themselves aren't once they're activated, they kind of like hang out in lymph tissue.
Okay.
Which is everywhere, and then because your blood passes through lymph tissue, and then once it runs into it, like, and it'll have its antibodies attached to the outside of it, and then as soon as it runs into it, the cell will start cloning itself a whole lot, and then just making tons and tons and tons and tons of that very specific antibody. It also is a mechanism to like tweak its antibody a little bit to like fit it even better. So that like if you run into something like 2 or 3 times, by the time you're on the 4th time, your body will recognize it so quickly. So there is caveats, of course. Some things you lose immunity to. For example, tetanus and diphtheria. You're supposed to get a tetanus shot every 10 years because it wanes. The cells forget that they're supposed to keep existing, and you have to keep boosting it, telling it.
Right, because their body's like, we have to deal with this in forever. Why do we?
Something like that. It just, and there isn't really a way to predict which ones need boosters and which ones don't. Like, technically, your polio vaccine, you might need an adult booster, maybe, but like hepatitis B, you get your hepatitis B shots, you're covered for life. But like, that's the thing with the coronavirus vaccines, is we don't actually know if you're covered, how long you're covered for. Like, the best data is like you're good for at least 6-8 months, but we don't actually know if you don't need to get a booster after a year.
So I've had this question in my head, and then I think I asked it before, and I'm probably not going to get the answer. So my question was, if you have the coronavirus and you defeat it and you can go back to work or whatever, and the whole point of a what do you call that? A vaccine is to give you that same immunity that you would if you had beat the virus anyways. So you get the vaccine. Now, what's the difference between getting the vaccine and surviving coronavirus and then getting immunity from that? So my thought is that why do I have to get the vaccine if I've already beat coronavirus? Now we hear talk about this, but it's kind of the talk is just like, I don't.
The thing is that sounds legit, but we don't know. And there is decent evidence that if you don't get sick enough with the coronavirus, then you don't make enough antibodies for it to be protective against you getting it again. Because there have been cases of people getting it more than once. Mm-hmm. It's usually not like immediately back to back. And it's usually, okay, sorry, what were you saying, Chris?
Oh, I was going to say the second time is usually worse than the first time too, for the people who did get it twice. Usually the first time it didn't bother them that much, but the second, sort of like the vaccines even, the second dose of the vaccine usually affects people more than the first one, I think.
Mm-hmm. Honestly, mine was the opposite, but I think that I might just be an outlier. But
you're complaining about your arm, but
yeah, I know, but I was like sick after the first one, and the second one, my arm just kind of hurt. So I don't know what that was about. Maybe that was just me. But the point is that if people don't get sick enough, and this happens with chickenpox too, is if you get chickenpox when you're like 7 months old and you get like 7 spots on your arm and that's it, you probably won't be protected, and you're probably going to get it again, or you'll be able to get it again. So you have to, like, because that's the thing, if your innate immune system clears it without your adaptive immune system, because I remember I said it takes like a few days for it to get going and your B cells to realize like, oh, I'm up, this is mine. Okay. Then if you clear it too quickly and it just doesn't have the time to mount that big strong response, then you won't be able to recognize it next time. That's another reason you can get the cold over and over again. It's also because they're like different species, but like you can get sick with some things over and over again.
Yeah, because they used to say like, you've never had the same disease or the same cold more than once when we were a kid, and we always think, whoa, and then they would use that to explain like basic evolutionary biology or something.
But like, for instance, if you get hepatitis B, you can clear it on your own and then you don't need a vaccine.
Neat.
That's a thing that can happen. But like, we know that because we have years of science to prove that, and we've we've done this research. Hepatitis B has been around for so long, and we've known about it for quite a while. So, but this is the thing with the coronavirus, we've still only really been studying it for a year and a half, right? So we just don't know the answer to these questions. So we're taking the more conservative side of it.
Yeah, I think that actually does answer my question so quite well. But then again, so you get coronavirus, and then you get the vaccine, and then you double up. But then I guess that begs an ethical question. If I get the vaccine, especially someone like me who is self-employed, I work from home because of the coronavirus, and then and I'm young and healthy, why would I get the vaccine over someone who's, say, I'm taking, like, that dose is not going to someone who might possibly need it more.
Another point with that is even like the age specific things, like so like most like 5-year-olds, between all 5-year-olds, they're like relatively similar, right? But then if you look at all like 75-year-olds, they're quite different. You've got a huge variation of like amount of activity they can tolerate, like amount of like every other function, right? Because as you get older, you become more diverse, right? You've lived that many years. So even doing it by age alone is like kind of complicated, because like if you have one 75-year-old that's like maybe not working anymore, but they're still like active, they have a garden, they're like getting up every day and doing this, and they're maybe on 1 or 2 meds. But then you have another 75-year-old that's like gets breathless from walking around the house, and they're on like 15 meds or something. Like they're not the same. So, but then it becomes so complicated that at some point you have to just make distinctions.
Right? How do you do that without being racist? Like if there are certain groups that are more predisposed to it, and like how do you figure out whether those groups are predisposed to it because of their poverty, or because they live in high density urban areas, or whether it's actually a genetic thing with their ethnicity that's causing their predisposition to catching it.
Live next
so we're definitely dancing around something right now. So I'm just going to talk about it because I was looking at Manitoba. So Manitoba is offering, the way that they're doing their vaccine rollout is it's by age, but then they also have different ages for their Aboriginal community. So it'll be like, for example, I don't know what's actually happening. It'll be like 60 to 7-year-olds can go, and Aboriginal people from 40 to 60 can go too. So is that a problem? Because it is affecting people of Indigenous descent more often, but is it because like it's definitely affecting people living on more remote reserves for several reasons. It's that like they're living together, there's more poverty, there's sometimes healthcare is quite far away. For instance, I knew a person that lived on a reserve in one of the territories who was telling me about how they only have a dentist in town once a week. So there's only dental work once a week on one afternoon. So it's completely different the way that they receive healthcare. So they were getting hit pretty hard. So
plus they get national healthcare if you're...
That doesn't affect it. That just affects funding, really.
Oh, okay.
And it does affect drugs as well. But that's mostly a funding issue. So if you have a treaty card and you go to a hospital, it's paid for by the federal government, and that's like a higher up issue. They've come up with a bill a while ago that you can't argue about who's paying for it. Like whoever pays for it, and then you can argue about it later, because there was a case of a child who ended up passing away because they were having arguments about who pays for their healthcare, which is ridiculous. So there's improvement. It's not perfect, but there is definitely some improvement.
How do you square that circle, though? Just like speaking hypothetically, not to say that you've got the answers, because obviously nobody does, but like if you've got remote communities who are highly susceptible to an infection, but they're more sparsely populated, but their access to hospitals are smaller hospitals that are less capable of handling an influx. What's more important, like an urban core where people are living in high rises and all shopping at the same spot, or a remote area that's going to cost more to treat fewer people? Like, is there a way of...
Well, you kind of answered that question by saying it'll cost more to treat fewer people. Like,
But you
at the
can't
end
just
of the
ignore them
day,
entirely, right?
no, you can't. But like if you prevent it, then it's going like, because if you have a community and that everybody gets the virus, and like even if only a few percent of them need to be intubated, that's still too many for like the nearest hospital to do. Then that hospital is like paying so much money to be doing all this. They're having to bring people in. So it's still not at all cost effective. Like, you do need to like, I'm sound very callous, but we do have public health care and we're spending taxpayer money. So we need to be on top of what we're spending. But anyway, that's a different discussion.
I feel like a lot of that is also
there might be some political motivations
it's also
for this
like
as well, which I don't really want to bring up.
Experience in these matters are like a lot of what we did to set up the healthcare system was from lessons learned before we had set up the healthcare system. And now, but the thing is, we didn't learn all the lessons, and now we have some lessons that we're learning right now that and honestly, it seems like some of the lessons that we had learned before have saved a lot of people's lives in this last 2 years alone. But we're sitting here going, well, it could be better, or it's terrible or something. But either way, what we need to do that to actually fix it would have long-term retrospective studies on this.
Like in 15, 20 years, we'll have a pretty good idea of like some of the things that we did wrong. But the other point I wanted to bring up is they are trying to cause, we also are trying to like have there be the least amount of death as possible from this virus, and like suffering, being in hospital for long periods. And in a population that is living in like relative poverty, that has some of those risk factors that I was reading. I didn't even finish it. There was also chronic kidney disease, obesity, and smoking. Those were the other ones that I didn't actually mention. But in a population where these chronic conditions are at a higher rate, and all the other factors we talked about, like access to healthcare, then they're definitely going to get hit more. And we can't, like, that means that there's going to be a higher rate of people suffering. So we need to intervene, because what's healthcare for if not to relieve
giving
suffering?
Those people vaccines first will save everyone more money in the long run. It's not even a racial issue. It's just these people, if we give them the vaccine, will save a lot of money because this. But then at the same time,
they're disproportionately affected. And like, the reason why, is it because there's like genetic things that are specific, or is it because of like more factors related to socioeconomic status? We don't know that, and we don't have time to figure that out right now. We just know that they're more affected, that some people are more affected. So we need to be targeting those groups, which is the same reason that you're also targeting people with advanced COPD and like people with like cardiovascular disease and uncontrolled diabetes. Like, it's the exact same thing. We're looking at risk factors and trying to target those groups so we can have the most impact, because we know that the vaccine rollout's happening slowly. So
but
you kind of have to
ask a question
go
about, because like we socioeconomic status, but then something as banal as, say, grocery clerks, top of the list, male, like Canada Post employees, probably go pretty high up on that list. Pharmacists, doctors, obviously the nurses, and all the healthcare.
Healthcare was like phase one.
But like, does the person working in human resources in a hospital that can do everything there, do they need it as much as, say, a nurse?
They so there's a couple points to that. The nurses, like the actual people working on the units that had COVID, got it first. But the other thing with vaccines is that they come in like multi-dose vials. So I think Pfizer, there's 6 in a Pfizer's first to come out. There's like 6 doses. So you have to like vaccinate in groups of 6. So
there's just an extra person there.
Yeah. So say you have 14 people on your COVID floor. Okay, so you vaccinate all of them, but you can't just chuck out the last 4 doses. Did I do the math right? Something like that. Whatever. You can't chuck out the rest of the doses. You need to give them to somebody. So you choose 4 other people. And that's pretty much the reason why I got it, is because they needed other people, because they can't just chuck out the rest of their bottle. Like, you need to vaccinate enough people.
You're not a bad choice, because you're potentially going to be working in the pharmaceutical workflow
I will be starting like, a month from now. So I'm I'll be working with them. So
yeah.
Um,
So one thing, I don't know if you want to go, I kind of wanted to backtrack just a bit, because when we're talking about risk factors, and we're talking about this thing, and it seems obvious, if your body's more fragile, you're going to have a bad time with COVID. Now, what about these one thing that happens to younger people, which is a massive risk factor? Healthy young people seem to be, especially people around my age, it can develop complications, specifically.
So there are long-term complications that have been found. I
also wanted to bring up cytokine storms.
Yeah, it's a cool name for something very, very horrifying. So the best way I can describe what a cytokine storm is, your immune system is filled with positive feedback loops. So you see something scary and your body says, oh no, that's scary, I have to do something about it. But then in doing something about it, that continues to activate the scary molecules part. So you just keep attacking over and over again. And of course, you need to have some way to abort a positive feedback loop. But sometimes those mechanisms fail. And when that happens, that's what the cytokine storm is. So you get so many of these pro-inflammatory molecules that are telling your body to attack. Something's wrong, do something. And basically it just runs out until you die. And that has happened with coronavirus. And it happens with other viruses as well. But it is a thing that can happen. So
how, because this happens mainly in younger, stronger
individuals. I don't actually know.
That's at least what I've come across, but it seems like a scary thing, like, oh, that could happen to me, but like, what are the actual chances of something like that happening?
Well, if you're excessively fit, it can affect you too, because if your heart's used to pumping because you're jogging and your heart's really strong, any disturbances in that can lower your blood pressure to heart disease levels, basically. And when you're less capable of being more active, like you're used to being, like professional athletes, because they're not doing practice and all that kind of thing, you could get a case where their lungs aren't functioning effectively because of the blood flow.
Yeah, I've come across that too. When I'm in kind of the higher end of being in shape, so when I'm like pushing myself harder, I find it's somehow easier to get like a cold or something, because I'm pushing my body so often, and then like maybe it's because I'm not getting as much rest, or it's because like you've specialized your body over the course of a couple weeks to be this good.
I mean, like lifelong athletes, like professional swimmers and bodybuilders and stuff.
Well, they're pushing their body
because of how much muscle you put on and how much strength training you do. That's when you can start getting blood pressure issues or fainting troubles just from sitting down and standing up, because a resting heart rate is usually around 80, but some like cyclists and stuff, their resting heart rate's at like 40.
Yeah, I was having problems with that when I was living in Ottawa, and I was cycling a lot, and I actually had to slow down, and because I was actually unable to maintain enough calorie intake to even
the thing is, even if you are eating like 10,000 calories a day, I think that's what Michael Phelps was eating, but even if you're doing that, you're still pushing your body in a way, so it's still going to have effects, like for sure. And just responses to cytokine storms, it kind of happens all over the place, like
it's just random bad luck.
Yeah, I think so. I'd have to read more into it.
So that seems like a risk factor that you really can't control, and you shouldn't should we even be taking that into account?
Well, the thing with risk factors is that the risk factors, they're not a determination. You can be a person that has cardiovascular disease and diabetes and a lung condition, and you're obese and you smoke, and you could get coronavirus and be fine. Like, they're factors, they're not guarantees. They're just raising the percentage chance that you're going to be hospitalized. So that's an important distinction too, is like, because I've seen people that are like, well, I have diabetes, I can't go out. And it's like, well, just it's very hard to wrap your head around statistics. They're not obvious.
This brings us to actually a point that I think we wanted to get into, was that of, because we have all the statistics and we have all these numbers floating around everywhere, and we're like, this number of people did blah, 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 and they don't really actually mean anything. When someone tells you like 43 cases of coronavirus in this town, like just yesterday, and it's like, oh no, wait, what effect, like how does this what effect does this have statistically? Like you can't just take a value and in a vacuum and have it be useful.
You need context.
And
Even saying something like you have a 2% chance of getting coronavirus and going to the hospital, like it's so hard to know what that means.
Right. So I feel like we're pretending as a society that we're actually data literate when only few people are. And you can make something look very sciencey. You can stick a graph in there and make the graph look really nice and have
use big words,
and all of a sudden it's just like, this is science, and you're just like, wait, what's the p-value here? How many people did they actually use?
We don't always really know what the number, even the people doing the research don't always know. You come to a number and you're like, okay, here's my number of people doing this. And but we don't really know what it means overall. But
we do know the constraints, and they're not reporting the constraints to their numbers, and that really bothers me as a data scientist. Like they're not saying we got 41 people and 40 of those 41 people in the city were all at the same party. That's totally different from 41 separate individual people spread all across the city.
Yeah.
We're talking about something that spreads exponentially. Knowing whether or not they all caught it in the same spot really matters when you're talking about exponentiation.
Well, it's not just
and that the only time it seems like the only time that they do report that is to like shame people. So they'll report it near Christmas time, being like, look at the super spreader party. Don't have your Christmas family over because this party had 30 people at it and all 30 of them got coronavirus and one of them died. Like they're using
they got hit by a car, but that doesn't matter.
Yeah, don't worry. No, they got hit by a car, but then the rest of their family was in the hospital, so they couldn't get it.
That's the other thing. Like their death numbers, they have a really complex formula of how they calculate COVID deaths versus regular deaths, and there are people all over the place who don't even realize that those are factored in.
Yeah, they died of
the
shock.
fact that somebody with diabetes died of COVID, there might be 3 of them and only one of them get counted in the COVID deaths number because of the factor they use to iron out those averages, right? But people aren't being taught this by the news media who are projecting these numbers. They should be teaching people to think critically about the figures that they're reporting while they're reporting.
Well, we were looking at one right before we started. Megan brought one up, and it was the Canadian government site, and it's like, here's the new numbers, but then it had like less than 100 people surveyed, and it's shows that
one was specifically like mental health, because I wanted to talk about at some point talk about the mental health effects that this has had. But then I was on Stats Canada because I was like, oh, I could grab a couple stats, but they were all like, we surveyed like a couple hundred people and here's how it just was bad science. Like, come on, Stats Canada, I expect better of you.
Yeah, they were definitely aiming for a certain target. And
the other thing is the types of variants that they're looking for. So some of the tests don't detect variants as well as other tests, right? Mm-hmm. Yep. So like not telling people what you're measuring doesn't help them make educated decisions based on the numbers you're reporting to them. So in my mind, I'm thinking like, well, why even bother giving them numbers? If nothing else, then it's just some sort of vague idea. So that, the difference between 100,000 people and 1,000 people, that's basically all they're telling you with these daily reports. But every state, like New York especially, Cuomo was on TV every single day for like an hour in front of cameras telling people exactly what numbers are what. And then you find out 6 months later that he was lying about the numbers the whole time.
Oh, yeah.
So like,
I knew that was going to come out.
What benefit did that provide anybody other than giving him an Emmy for a daytime drama?
And just creating more fear, really.
Right. That's all they were doing is tear-jerking people and making them watch because people were scared for their lives. And that's the opposite of what you're supposed to be doing.
Well, like, why would anyone think that a scared society would be compliant?
Yeah, we've seen that doesn't work.
Like, that's not, like, you need to be honest with people. But it is, because, like, it's hard to explain numbers for one, but another thing I wanted to talk about with numbers is the vaccine trials having like wildly different efficacies. So your Pfizer Modernas are both over 90%. You're looking at like the AstraZeneca Oxford vaccine that has like, is it 60 something, I think 67% or something. And that's scaring people away from it. There's other things with that vaccine, but just the efficacy numbers. But what is, they were running completely different trials in completely different places with different levels of coronavirus. So when Moderna and Pfizer were running their trials, there's still a relatively low number of cases in the world. And they were running it like Pfizer had some South Africa, Moderna was mostly in the States. So it was just depending on where they were running it and the way that they were running their trials, they got different efficacy numbers, and what they defined as efficacy wasn't exactly the same either. The most important thing we can learn from those trials is that the rate of hospitalization in the vaccinated groups is 0, always, in all of them.
That to me is the key number, is the R rate. The whole point was to reduce the transmission rating so that less than more people are getting infected. In other words, if there are 10 people infected today, you don't want there to be 11 tomorrow. Right? Or there to be 20 tomorrow.
But the other thing is that if everybody in the country gets a cold, it'll decrease productivity, but that's not the end of the world. The problem is that people need hospitalization. So if our vaccines can make it so that if you run into coronavirus, you get sick for 2 days, but then you go back to work, then that's not actually that huge of an issue. Like, it's better if you don't get sick.
The definition of efficacy would be different, though, for those.
Yeah, of course. And the way that they were detecting them with different tests, like the timing of when they were like testing, were they actually testing people? Because the Pfizer and Moderna ones, I don't think they were like testing people monthly or anything. Like, they were just waiting to see if people developed coronavirus. So maybe there was people that did develop coronavirus, but they were just like, I'm a little sick, but whatever, I'll just not do anything, right? So maybe
they were asymptomatic the second time, and they're basically just going on people's opinions. Hey, how do you feel? Do you think you need to come in for a test? No, I'm good.
Yeah, but then like we'd have to, like, there's so many details. Trials are so unbelievably complex. I've spent months of my degree learning about reading trials and looking at whether it was double blinded properly, and whether all these like little factors, like, they are incredibly complicated.
And that sort of gets us back to like the whole development process of why things take so long, because you absolutely need peer review in order to be able to compare apples to apples, first of all.
Yeah.
And second of all, you need time to have elapsed in order to look back and see what affected what. Because
one of the things that
correlations while the chart's moving.
Mm-hmm. And one of the things that they did with the coronavirus vaccine trials, they did this, all of them, was they allowed you to submit data as it came out. So most vaccines, you run all of your trials, your phase 1 through 3 trials, and all your preclinical data, and then you get that, it's this massive package, and then you submit it to your like FDA or Health Canada or whatever your government body that approves it is. And then they have to go through it. So that takes a lot of time. Whereas with the coronavirus, they were able to submit it piece by piece. So this sped up the process quite a bit. Though I'm going to say that I didn't actually finish talking about the trials and the phases of the trials. So we were talking about lab studies and preclinical trials, but there's like 4 phases essentially. But your phase 1 trials are the first time that you put the vaccine into a human, and it's like usually like 40 people or something, and you just basically do it to see if they like get anaphylaxis. Like, you're not really looking for anything other than safety. Do they have any really bad side effects? And then once that study is complete and written up, then you go and do phase 2. And I think they were kind of running things concurrently a little, and like their phase 2 was looped into their phase 3 as well. So they took some liberties to allow things to go faster. But your phase 2 trials, you're looking at 50 to 500 people usually. And you're looking for you're trying to figure out what the best dosing strategy is as well, like 1 or 2 doses, how far apart. And you're still looking a lot for safety signals and making sure people aren't having horrible reactions to it.
And storage and administration and all that kind of stuff, because you're invariably going to come up with other factors like nursing or education for how to keep things below a normal temperature. And
yes, I'll get into that in a moment. But
yeah.
the phase 3 trials is when we get like thousands of patients. And usually vaccine trials have like a couple thousand at most. The Pfizer trial had over 40,000, which is like ridiculously massive. So they would have tons and tons of people. And it's in the phase 3 trials that you start looking for efficacy. Because you don't, in the early trials, you're just making sure it's safe. But in phase 3, when you are looking at efficacy, you're obviously still looking for safety and all the other signals as well. I did mention phase 4 trials. They're post-marketing. So they're things you do after the drug is to market. And those are sometimes in like regular people, not people in trials. Because it's hard. Like when you're in a trial, they'll be like, they won't have people with like too many comorbidities, but some of the trials tried to do a better job of like bringing in people with autoimmune diseases and people with like well-controlled HIV and things like that.
And there's another aspect to it too. Just to point out, not to say that you missed anything, but with those, they're also reevaluating the way that they were testing before, like the way they calculate their preclinical trials. They're also looking at changing those diagnostic figures, or basically the meta-analysis of their abstracts. They also have to change and adjust as the trials are continuing on regular people. Because if you see one sign, let's say the blood clot thing, suddenly that makes you have to put an emphasis on tracking blood clots for all people going forward, just in case, right? So part of the trial process is also reinventing the assessment process.
Mm-hmm. And like there's another issue with sometimes the blood clot, like you don't have enough people to detect if it actually causes blood clots. If you have an event that's so rare, it happens in 1 in 10,000 people, well then to see if it's like true and find the real rate, you need to try this out in like tens of thousands of people. So sometimes rare things just kind of either get missed, or we find one person in our trial that had this, but we don't know if it was from our drug or from this. So things are hard to track. And like science is hard and it's complicated. So scientists are doing their best, but like things get missed and then things get picked up by the media. Then the media tells people things that are not necessarily true. And it's not always because they're malicious. It's sometimes just because they're trying to make a story out of it.
And it gets filtered through politics. So it's how does this affect this identity group or that identity group, when it's like they're people, it's a coronavirus.
Well, and like the States is really bad for saying things like this red state has this much coronavirus. And I'm like, I don't care what party their senator's from. Like how many people are suffering?
Like, but they also had politicians saying not to give vaccines to blue states because
that's screwed up.
Like that's really messed up. Just let people die because they believe in something different. Like,
that's
there was so many like counter ethical events that happened through the states. So like I was standing on my head basically the entire last year, just unbelievable what they were doing, like promoting bleach injections to clean your insides. And
I will say that Donald Trump doesn't know anything about medicine. And in his Donald Trump way, he was like, I'm not a doctor. I don't know. Well, you shouldn't have said anything at all. But
the news reported it and repeated it over and over and over again.
That's the problem, really.
Fox and CNN and like instead of taking the time to teach people the complicated thing like numbers and math and how to read what they're being provided. Well, like information wise from the media companies, instead of teaching people how to hear what they're telling them, they're over and over and over again reminding people of things that are insane.
Well, and this is kind of also the other corruption of it, because right now you're getting faculties and universities who are supposed to be teaching exactly that as part of their curriculum in anything. So you're an artist, how to critique art, like how do you know what's good art and bad art while you make art? How do you look at art as well as how you make art? Well, you're in journalism. Well, you better know that. You're in science. How do you know if a something is real science or bad. But then they're like, well, the first thing you need to look at is to see whether or not they make a diversity and inclusion statement in the abstract. It's like, are you kidding me? Well, if they don't mention women, it's like, this is about prostate cancer. Yes, but what does it have to do with women? It's like, what? So now everyone's having to, they're being taught that the way to way to be critical about such things is just to find out how it's problematic.
You're taking shortcuts. Like, is this problematic, rather than like actually digging into the meat of it, which is way harder.
Or
we admit
especially
there's
in
so much to
science.
discuss. Like, it's so complicated and so varied, and there's so much for us to actually discuss. But the only thing you see on TV or read in the newspapers is the inconsequential BS and lack of reporting of data. Like, that to me is the bigger problem than the way things are being rolled out just as an emergency procedure. It's way more important to me that our media has failed us epically over the last year.
Yeah.
Like, we, as a society, rely on them for information and general public awareness. Well, we rely on them entirely.
And on the other side of that, I feel like there's also this, the cult of ignorance is kind of coming back, where you get, it's okay, my ignorance is just as important as your knowledge, and you get people who think that they know the answers because they've been watching the news for so long. So you get this, not even just the understanding of how to do the media, but understanding of what it is to actually think about things too. And that, or I don't need to know, I'll just do what I always do. And this, people being okay with being ignorant, people being okay, well, the experts don't actually know what they're talking about. And that's that kind of like, I guess that would be like a right-wing cynicism, where you get, well, the experts don't know, I'm just a farmer, I know everything I need to know about life right here in this shovel. It's like, well, there is a zen to that. Yes, you are right. But there's a lot more to life. And an expert is, an actual expert, not like a CNN expert. There's a difference. Is someone that's put the work in order to become an expert. And they're an expert and a master of their craft, be it science or architecture, whatever, for a reason. And that demands the respect of attention. But it also demands the respect of another expert going, I don't know, let's have a discussion. And when you only have a couple talking heads and with a who aren't actual experts, with a predestined end to that conversation, which happens in, like, I guess, again, stop watching the news. But then you go on YouTube and you can find scientists discussing, their findings with each other, going, I don't know. And then they come to like, okay, well, we've had a good discussion. We learned a bit. We'll post our notes and our citations down below. And that's an actual discussion.
Well, to me, what's really offensive about this is that people are withheld from the information. Like, they're not even allowed to go look up journal articles because they have to pay for a membership from a scientific journal.
That bugs me.
So they rely on the news media to report on someone else's study, but they won't let everybody read the study, except for select studies that they post on the government website. Like, how is that encouraging proper procedure and protocol be followed when you have a health advisory warning saying everybody should not meet up with 6 people? Then everybody thinks that, I'm going to game the system, and like, I can just say I live with this person and this person's my neighbor. So
and they're really short, so they only count as half.
Like, it's not about the rule. This guideline, this rule that's in place for this week is supposed to just be to give you an idea of how to be a responsible adult for yourself. It's not meant to try and get around it, like you're going to trick the coronavirus or something, But that's the pitfall and the trap that you fall in when you don't educate people properly, and you become like a gatekeeper to knowledge, is that people are going to make bad decisions based on your advice because you're not telling them everything.
Mm-hmm.
And sometimes it's not just that you can't access the information without paying, is that, like, I'll find really interesting paper that talks about how to prevent the spread of coronavirus, and I'll send it to like my friend who graduated high school and hasn't done any post-secondary education, and they'll be like, what the heck is this saying? Like, because there's so much background knowledge to reading medical journals and medical things that like even people in the field don't even follow it, to be honest. I mean, we have a responsibility to figure out why we don't understand and still use the information, which I did say we have a responsibility and we should be following that. And if you're not, then you're bad at your job. But like, they're complicated, and we can't expect every single person in the population to understand these journals, which is why we rely on journalism to disseminate the information. And if they're doing a bad job and they're doing it politically, then the people that are just trying to do the research are sitting there like, what? I just wrote a paper about like how, like COVID's affecting mental health. I didn't mean for people to say don't wear masks and go out and party anyway. Like, that's not what my intention was. But now you're painted.
The virus doesn't affect your serotonin directly. It's like, not explaining the action of mechanism, right?
Yeah,
it's the isolation that causes the depression and serotonin problem, not the virus itself. But like explaining that to people should be the journalist's job.
Yes. Yeah.
And there are good journalists out there.
Of course.
And like a lot of them are doing kind of like you see these journalists now who are going off and doing their stuff independently, and they're going and finding other sources, learning what they need to learn, going beyond, well, I'm a journalist, I only need to know journalism things and report what I see. It's like, no, well, in order to report what you see, you kind of have to learn a bit of it. And there are some of them out there that are doing it. They're on the fringe, and there are a lot of them are very weird, but they're better journalism than a lot of the thing is that
we wouldn't be okay with that with any other profession.
No.
Where like if there were surgeons doing heart surgery and say, well, most of the heart surgeons are okay, like that would be an issue for any professional
theory.
Métier.
Theory here. Now, my thought is the problem isn't with. Okay, the problem is with the journalists. Obviously, you have an ethical duty as a journalist, like smarten up. But the medium is the message, and the problem is also with the cable television was it made bad TV. The only thing it was good at was showing you sports, and even then it was you can
and now the weather.
Yeah, and the weather, and the one weather channel with the 3 colors, and beyond that, it was a bad medium for disseminating information. It was better. You get those, and you saw people who saw the promise in it, like Moreau, Mr. Good Night and Good Luck. Go look him up. He's one of my heroes.
But some people look at Tucker Carlson and Lou Dobbs and Sean Hannity as if they're the same thing as Larry King. You know what I mean?
Right.
They equate them to the same level of professional integrity.
Because in the medium, they're given the same authority because they're on the screen. And that equals that's an equality of sorts. That's an equality of authority. And we should be more, it's like, oh, wow, he's just talking out his butt. Or what's that woman on Rachel Maddow, who's just got her patented righteous indignation. It's just like, you almost know exactly what all these people are going to say based on their contexts in the medium. And actually probably how long they're going to say it for. So it's like, oh, it's been 30 seconds. They're going to wrap up now with a half-second conclusion. And so the whole point is that the medium doesn't disseminate information. It's a show. You're watching a show. And there's a difference between a journalism and news as entertainment. Like, so I don't know. But the problem is also that the actual journalists, again, because of the medium, are sent out to the fringe. And you get places like YouTube where like, I'm actually doing journalism. I have it on my channel. Go look at it. But, then YouTube says, no, we're going to go with only you can't say stuff that, we have deemed to be false news or fake news. But then that's not who determines who the fake news is also the weird part. And this, when it comes to coronavirus, and like you guys said, it changes every day because we learn new things every day. So you can't come to well, if you say this, you're wrong, so we're taking your video down. Well, the thing is that if you said that 3 days ago with full knowledge of what you think and you use conditional language like a responsible person, then, it would happen, these kinds of
indications things look this way at the
yes.
present time. Yeah.
But if you say the word, Trump now, or you're not allowed to use Trump's voice on YouTube now, which is, it's asinine. Because as much as I hate the guy, he was a player in our society, so we have to talk about him. You can't just not talk about him. That creates more problems than it's worth. If you don't,
that would be the definition of ignorant.
Yeah, we're enforcing an ignorance to go along with a changing public opinion, as kind of in the Walter Lippmann sense. Go read that book, because public opinion isn't set in stone. And if you're saying what public opinion wants you to say, you're not saying anything scientific, because in 3 weeks, guess what? It's going to be different. And we're noticing this now as a society, going like, wait, everyone was saying this here, and now everyone's saying this now. And we're starting to see it because we have these things cataloged now on the internet, the way we've set it up. And I guess that might make us smarter over time, but if we educate ourselves, we could probably be smarter quicker. So take some responsibility for how you ingest media, I guess.
I just wanted to make a point as well that journalism, like, I feel like there's probably a lot of cynicism in journalism, like people that come fresh out of their degree program and they're all excited to report on the news and like give people stuff, and they write their first article and then they get told, well, you actually are implying the other political view than what this station is, so you need to change the wording. And they're like, what? But this is more accurate to what's happening. And I feel like that, like, indoctrination, essentially, I don't really want to use that word, but like, you're taking these young, bright people and then pushing them in a way, because again, you can, if you do like really, really hold true to those morals and ethics of being a good journalist, then you have to work in the fringe, because there's really nowhere else for you to work, because you can't report for CNN or Fox News and be like unbiased
or a centrist.
Fair and
or that
you're looking for.
Yeah, I'm choosing like intentionally ridiculous. Like, I can't pretend I know everything about politics. That's not my background, but yeah.
No, but I used to learn politics from journalists, and now I feel like I have to teach journalists how to speak properly when their job is to be a political reporter. You know what I mean? Like, if you don't know, then don't write something about it. Like, I don't write books about biology or articles about biology. I'll write one on neural networks or something I studied. But as a journalist, you should not be publishing things that your editor chops to pieces and makes like digestible for their little, meat chaff.
Well, and when we talk on this channel, we usually sometimes we forget, but everything we say definitely comes with a caveat as this is as far as we can tell. And we try and show our where the liminal spaces of our knowledge start and where we start speculating. We use reason to go into those spaces as much as we can and to show what we already do know. But we don't claim it's like, well, we did a thing on neural nets, so therefore I must know everything about neural nets. No. After doing that neural net episode, go watch it. I now have an understanding of what that technology is. That doesn't mean I can build one. That doesn't mean I can, implement one. But now I'm hopeful that there's this technology out there that I now have a basic understanding of is, something that shows promise for our society. So, and this goes to bring it back to the coronavirus. Well, a lot of us, most of us, don't have that knowledge. And in fact, the people that are talking about it are the people that have the least knowledge, because they're journalism students. And the people who do have the knowledge are working their butts off in labs right now and don't have time to say anything in front of journalists. And if they do, it's just like, okay, I've been doing pipette stuff all day.
And the other thing too is that scientists use conditional language a lot because you don't know the answer. We're like, yeah, we think that, this will probably we think that you'll have to get a booster shot after maybe a year, but we don't really know that yet. And the journalists are like, everyone's going to need a booster shot after a year. Like things get, because it's really, really hard to portray scientific information when we're not like, we don't know all the details.
Well, imperative tenses are sexy.
Well, and people want answers, and that's not wrong. It's not wrong to want an answer. Do I need a booster? It seems like an easy question, and people want an easy answer and they're looking for it. And if you're making a show rather than news, then you're going to give people an easy answer, but it might not be right.
I think a good answer is a more refined question. I don't think there's anything wrong with answering somebody, I don't know this, but I do know this, and this is why we don't know this. Like, that's a better answer than telling them the wrong thing just for expediency's sake.
Well, because an answer is an end to the discussion. Okay, good, period. But life doesn't work like that. The discussion never really ends. And so the best way, I guess, and I like how you put that, it takes you down the right track instead of ending the sentence. I like how you put that, though. Better.
I think there are ways to be honest about our own ignorance. Like, I don't think they're mutually exclusive to say just because I don't know something, I don't have any answers for it. Like, we know a whole bunch of things about viruses in general. The fact that we could apply mRNA vaccines towards this type of virus just implies that we had some prior knowledge to how viruses function and how RNA works, right? So it's not that we came from nothing, but when they're discussing the vaccines and the rollouts, they don't mention ethics. And if they do, they don't propose any like active solution. They don't mention the data procurement. They never talk about the bias of the studies. Like, it should be reminded every single time they have efficacy rates shown on TV that they're produced by the suppliers who stand to profit a huge ton of money from taxpayer-funded research to produce and sell this vaccine.
Gallup is a business.
The proof of that is they were refusing to give out the intellectual property for it. They didn't want outside companies producing their vaccine.
Yeah, I just found the mRNA sequence for, I don't remember which one, I think it was Moderna. They posted it. It was like a couple weeks ago,
it's
a week ago
GitHub.
Or something. Yeah, like I found it. I looked at it.
But they were
there
trying
was a
to
lot
stop
of letters.
people from seeing it.
Yeah,
and they're still stopping people from producing it, and their only reason for that is a profit motive. Now, to me, that should be on the news just as prominently, if not more prominently, than daily numbers, because daily numbers are meaningless. That's important. And stuff like that, it doesn't take like a Pulitzer Prize winning journalist to figure out. That's stuff that everybody cares about, and everybody wants to know about, that they're not reporting.
And the thing is, they assume you know that. They're like, yeah, obviously Pfizer ran Pfizer's trial. But the thing, they did bring in people that didn't work for Pfizer. Like, it wasn't 100% Pfizer employees, but it's still,
Monsanto says that about the universities they pay to get their studies and stuff done. But when you're sponsoring somebody's research, the researchers need that research funding.
And if you actually open the study, it'll say in it that somewhere, probably at the end, that yeah, we work for Moderna or we work for Pfizer. They'll say it. It will be in there because nothing could be published if they don't declare that there's conflict of interests. But they kind of and you'll see studies now, even not related to coronavirus, just random other studies that are comparing two drugs, and then you'll be like, oh, well, this one works for Eli Lilly, who produces one of the drugs used in this study, so that's pretty sketchy. But you try to that's one of the things that, what I mean is, you get a new trial on your desk and you have to look for all these things. It's not obvious. There isn't there's lists and guides of how to read studies, but again, it's complicated.
So do you guys want to maybe take a break here and let the video render, and when we come back we can cover the rollout and some more World Health Organization type of stuff? Maybe we'll do a bit of a timeline when we come back in for part 2, just to get an idea of where we came from to where we're at.
Sure. See you in part 2.
See you guys.